Okay, so I've been sent this radio to do some work on. I believe it just needs a conversion to New Zealand channels. So let's open the thing up. Okay, so that has been unpackaged and probably used before. Let's see, where's that magnet from? That's interesting. 2013 Cobra 29. One with the flashy display, which is a bit of a shame because when you convert this to New Zealand channels, the frequency doesn't change. You still get the same frequency display. It is possible to hack it and inject your own serial commands to control that display, but it's not worth the effort, to be honest. It's just a lot of work to do that, and it's just not really required. As long as you know which one it's doing, it's fine. Anyway, let's power this up and see what we get. Powered up, and this is what I'm saying about the frequency display being on there. It's a bit of a shame they do that. I mean, it's nice as a feature. It's a shame because when you do a conversion, that doesn't change because it's just a channel referenced frequency rather than a actual frequency. So they could have done it as an actual frequency, but anyway, that's what they've got. So transmit. That's looking okay there. It thinks it's doing a decent signal, but if I look at the bird watt meter, it's doing 2.5 watts. 2.5 watts on the factory. Interesting. Or is it factory? Someone might tinker with it. Let's have a look. Yeah, it's about 3 watts on the whistle. So, yeah, that's pretty low output from a factory tuning. They should be able to get closer to 4 watts than that. That's pretty bad, actually. Okay, let's shove in a signal from the signal generator. 26.965. Let's do a minus 67 dBm signal. I know there's been some debate about the reference levels. I know Mike did a video on it about minus 67 dBm being the wrong level to be doing an S9 signal. But if you look at a lot of service manuals, they'll say 100 microvolts, and if you look at a conversion chart, 100 microvolts is minus 67 dBm. So yeah, go figure. I've always used minus 67 because that's what matches up to all the information I can find. But I believe there's differences between HF and VHF and stuff like that, which is an influence on that as well. If you look at service manuals, often it will say 100 microvolts. There we go, got a tone. And that's doing about S5. That's pretty bad, I have to say. Okay, well, let's just bump up the signal level. So S9 I had to put out minus 47 dBm. Just flicking on S9 is about minus 57. I don't think this alignment is very good on this radio. That's pretty bad, actually. And that's from factory, you would assume, because it looks like it's brand new. Alright, let's get this thing opened up and we'll get started. So yes, it does need frequency conversion because obviously it is on the other band and stuff like that. So, but yeah, it's amazing that the factory alignment is that far out. It's not normally that bad. They're usually better than that. So it's actually quite surprising. They're normally, at least 3 watts. But yeah, it's 2.5 watts. It was really down. And receive signal strength, it's just incredible, really. It should be a lot better than that. So I've got to do a conversion on this thing. Right, what do we have in here? Lead-free solder. So that's a KPC 1141/-K2. It's pretty simple, really. So that's basically a standard Cobra 29 board right there. And they just basically add on the front end to do all the display stuff, which is down there. Alright, so that's what a CPU, and because it's got weather as well, so weather board down there. I just have to mount in my my conversion board and drop that in there and hook that up and do a full realignment, and it should be all good to go. And I'll show you the end result once I've done it, I think. So I've got the radio apart now, so let's desolder the speaker, and I'll take the wiring and everything off as well. Let's do that now. Plug the wires at the back so I can move it around a bit easier. Okay, so what I've got to do, I've already done a little bit of work here. I've already sort of got things a little bit ready. It's got this mount on the side here for the EL backlighting, okay, electrical emissive backlighting. Now, it's a high voltage driver, but it's got some studs already on there. And I normally use the one I was mounting holes to mount this board. This is my modification board, which I had custom made. Well, I custom made it basically. Little PCB which I designed, and a custom made crystal oscillator. There's already screws to there, so it's the 3mm screws, so I just put a little standoff on there like I always do, and we'll bolt it on like that. Nice and easy. Stick a few wires on here and hook those up. I've got to modify the original circuitry to inject the signal from this into the radio. I need to actually there's a capacitor in here which I have to lift the leg up from and attach a wire to in order to tap into the circuit to replace the original frequency. So it's a pretty easy conversion. I mean, it's well known online, so it's not like I'm showing any sort of secrets or anything really. I'm just showing the way that I do it really. So right here, that square right there, that is the tripler coil. Right, so it's 5.12 megahertz, comes out as 15.36 megahertz from this coil. Right, that filters it out and tunes it to the correct frequency, makes it resonate. And it comes up here, and just there, across that junction, is a capacitor. So all I actually have to do there is desolder the leg of that capacitor there, lift it up, and put a wire on that leg on the other end, and that will inject the frequencies for these in channels using my custom board there. Okay, so it's a pretty simple thing if you know what you're doing. So let's desolder the cap. And I've got to find the cap on the other side of the board. It's in this mess here somewhere. So that's always the tricky bit, is finding where exactly where it is. That's about between second and third pin of this IC, so it's probably this one here. Check this over and get that leg out. There's the leg. Just like that. Okay. There's that leg there. I just pulled it up out of the wax. And I was going to attach onto that leg a little piece of wire from that board to there, nice and short. Get that right through the board. Make sure it's bedded into the wires. Right, that should be good. Now I want a VCC wire and an output wire. So I've got orange. I normally use yellow for that, but it's currently in a box in the garage somewhere. So I'm still not completely recovered from the flood. It's still not everything reorganised properly yet. I'm still trying to do stuff. This is the first CV work I've done in ages, months and months. Make sure it's right through the wires, you know, all through the strands, so it helps to make sure it adheres properly. And there. Basically try and keep the wires short as possible. So I used to build my own oscillator circuits with crystals I had made. I used to get crystals manufactured, and I was making my own oscillators, and it's quite a pain really, to be honest. It took a lot of time to actually build the boards and build the oscillators, and I was etching my own circuit boards at the time as well. So it's a lot of effort, and it's more of a time constraints really. It's just that's the thing which really made it a pain. Then one day I thought to myself, well, these are fixed frequency, why do I need to worry about building an oscillator circuit which can be modified and tuned and stuff like that? It's like, well, why do I worry about that? So it just dawned on me one day that I'm doing it the hard way. You know, it's just the way I'd already done it, you know, that's just what worked, and you know, but you've got these oscillators, it's like, well, just use one of these. You know, get these made instead of the crystals. The price was about the same. I didn't have to build an oscillator. It just made a lot of sense really. I just wish I thought of that aspect a lot earlier. It was a bit stupid really, but okay, let's just check the mounting positions and adjust the wire lengths to suit. I like to leave a little bit of slack so you can move things around if you need to. Okay, so that's the output one. I did an earth point. Well, there's one right there on that crystal, so that would be really handy. I'll just go straight to there. And the other one here goes down to the bottom of the board. Actually runs the same supply as the POL, because it needs a 5-volt supply. So I could actually bolt that onto the chassis now, actually, couldn't I? I actually went to go and get some crystals made recently, and the price has jumped up significantly. It used to be about half as much as it is now. It's incredible. You want like nearly $50 a crystal plus delivery. It's just horrendous. Currently looking for another supplier. I've used this one for years, but I haven't purchased any for quite a while, a few years, and because I had enough stock. But their pricing seems to have increased significantly. But I need to find someone else now because it just doesn't work with that pricing. It's just too expensive. I can't pass that kind of price on. It's just too much. So it's just lucky I built a bunch of stock up beforehand, because I've actually got I've got a whole stack of these oscillators. I had a whole bunch made, and I thought, right, if I'm going to do this, I'm going to do it once and pay less money for a larger quantity. If you want to get into that, I can. Just fits in there like that. Doesn't want to come loose. So that ground has to go underneath there. Just put some fresh solder on there. It's probably bloody lead free or something, I don't know. Okay, that's on there. Hope that's the right size. Yeah, just. Yeah, let's use tweezers, that'll probably help. Alright. There we go. It's attached. So I've done quite a few radios now, so this is pretty normal for me to just charge through it because I'm used to it. Okay, so I'm going to heat shrink that. Let's get it going. So noise is going to be bad for a little while, I'm afraid. Now I've got to attach the power wire. Just hole in the board, keeps it secured. Okay, turn it on. A decent earth point right there. That's probably another camera, isn't it? There you go. Alright. 5.1, it's 4.8 that side. This means there's less loading on that resistor, which might drop down the voltage to POL, which is probably not a good thing. In the past, before I had that board made, I would tap onto the resistor side because it actually worked out a lot nicer for physically fitting it. But it wasn't the best way of doing it. Let's put the power brick off. We'll check this on. Then in theory it should be on his in channels once I do the alignment. Okay. Done did. That should work. Do some basic testing, see if the thing's actually working. Okay, we have it transmitting on channel 1 is in. That's definitely working. Okay. Doing 2 watts. And it's pretty much bang on frequency. So the 10.24 megahertz seems to be right. So it's already transmitting on his inner band, that's all fine. It's just the receive is likely to be wrong because you can't actually measure that as easily. I'll just put this away. Let's get it back in again. That's done. Right. Let's check the VCO voltage out. Let's just try it out. So I've got it clicked onto negative input from the power jack. So we've got, if I try and show you if I can, underneath this bunch of wires, there's the POL and there's a resistor coming down here. You probe into that resistor leg, you can see that voltage there. Alright, that is 4.8 volts right now. That's on channel 40, sorry, channel 1. You go to channel 40, you see it drops down to 2.2. So that is actually too high. Okay, it should be much less than that. If I go to transmit, I'll say I'm on channel 1 now, so there's 2.2 there on transmit, and on channel 40 it's 2 volts. So I can go down by about a volt on that channel on TX, but this is too high, that's topping out in voltage, which means the VCO won't be locked. Okay, so I've gone around and cleaned the wax out of all the cans, so that can, this one, that one, have all got wax in. So I've dug that out. If you don't dig it out, there's actually a risk that you'll break the cores when you try and adjust them. It just helps to prevent accident happening. Now, this can here is the VCO, that one there. So that's one we need to adjust. So we'll chuck this together, chuck it in there, and we'll adjust it. Go the right way. There we go. Alright, so you can see how much I dropped down by. Set it, say 3 volts. And we'll see what that looks like at the other end of the band. So channel 40 looks good. Channel 1's 1.9. We go down a bit lower. 0.8. Let's go lower than that. We want it to be comfortably under control. So put 1 there, 1.9 there. So I think that's all good. That's channel 1 and that's channel 40. So that seems alright. It's an important thing to do, because if you do just rely on the fact it can transmit, then the transmit will work. As you saw before, it was transmitting. But receive wouldn't work because the VCO isn't locked. So I'll show you those voltages again just to be clear about what I've done. Okay, so on channel 1 receive, 2.1 volts, channel 40, 1.9. Okay, you see it goes the opposite direction. And transmit, 1.6. Alright, so it's well within the range of the VCO and the POL outputs. You know, there's no concerns here at all about how that's going to be controlled. If it's going too far out to the limits, what happens is that it gets very choppy, because it's putting out pulses from the phase detector, and that is then smoothed out. And if that's not in a medium point in the range, you can get a lot of phase noise and stuff like that coming through to the VCO, which adds to the emissions from the radio. That part done, so it will transmit and it will receive. Now I need to do the actual alignment. Right, so I'm just going to work my way through the service manual parts just to try and show you what the alignment is. I may cover all of it, I may not. It's a bit noisy now because I've got my CMU 200 running, because I need that shortly to do testing. And so I've got to do a check for L18's alignment. L18 is this one here. And I need to make sure that's set correctly, because it probably isn't now. I've changed frequencies. So I need to go into the junction of R17 or JP22. Well, JP22 is right here. So just stick the probe on that, and we'll go from there. Alright, let's just get set up. JP22, stick that on there. Okay, I've got a frequency there. That's the VCO frequency. So I just need to make sure that this is aligned to be maximum in the centre of the band to give it good spread. Now it's definitely coming up that way. Yeah. Oh. Yeah, about there. Okay, so we want it. Maximum peak. That's that part. Next one is to align all the RX system. Okay, so let's make sure I'm on the right channels. I'm 19, noise blanker and stuff like that off. Noise blanker off. And tuning centre, that's all fine, that's all there, that's done. Squelch turned right off, it is. Volume maximum. Yep, okay. IF gain maximum. And mic gain maximum, stuff like that, that's fine. So it's got a tune, so it's 2, 3, 4, 5, 6, 7, and 8, and 9 too. Yep, and 9. Right, that one there. So I've got to do that U shape there. Right. So I've got the signal generator running. Let's put this thing running on the right frequencies. 26.55. 30% my modulation. So what I'm supposed to do is tune for the maximum level. I'm supposed to get oh, I haven't got my rubidium turned on. I need that soon. got to set the level of the signal generator to obtain 2 volts on the voltmeter. Okay, that's fine. So I've reduced the signal level on the generator to try and get 2 volts. So it's about 110 dB or so. Let's just set that. Yeah, 110 dB is pretty close. No, so it should be giving me something. There's nothing on display. So let's tune and see if I can get that voltage level up on the meter there. What's this level on the here? There. Yeah. So I'm supposed to be tuning for the best distortion and sinode readings as well. So I think I've got to be looking at the same time. So we're getting there. Slowly coming up. Although to be honest, it's easier to actually look at the signal meter than anything else. Is that the screwdriver? Yes. That's very different. Very different. That's a very different setting compared to a factory setting, which is interesting. If you go by the manual, I don't trust it. I might go by my ears afterwards. We'll go back to that one, I think. And last one. Right, well, we'll see how that comes out. Does it align with the way I normally do it? I don't know. I tend to do it just off the signal meter and what I can hear. I'll just peak it that way normally. This time I'm using this new piece of gear, and which has got the sinode and everything on it as well. So we'll see. I mean, I'm not quite. I mean, 110 dB I've got on the output of the generator. Got a little bit of signal there, S1, so it's something. And I expect to see a better sinode reading there right now. Let's go back over and do it again. Let's repeat the process, and we'll see if I can get a better sinode. Yeah, I can't really peak because these numbers jumping around a bit, so it's pretty hard to see where the peak is. Let's just look at the meter. So sometimes that is easier to do. Right. They correlate pretty much anyway. Just couldn't quite see exactly where the peak was. Yeah. They are kind of matching up anyway. But I just like to use signal meters normally. Just easier. It's more visual, you can see a peak. About that. Yeah, those match up. It's probably not very interesting watching me do this, but that's just the way it is. It's pretty much there like that, I think. Go up to these ones again. So it is peaking right at the end, which is interesting. So the signal meter is agreeing with that. Right there is the peak on the signal meter. Yeah, the CMU is pretty much agreeing with that too. That's good. So I should go by that. That's a long way out from what the factory setting was, which is interesting. Mind you, the factory receiver was very low, wasn't it? That's probably why. Okay, let's do this one too. Yeah, if I just peek to the signal meter, it's actually pretty much agreeing with what the CMU is saying. Pretty much. Slightly better there. I'm looking at both at once. Oh, the screen's gone off the CMU, sitting there obviously getting bored. I can see that one here. That's not doing a huge amount. I might have to do it on my ear, I think. Yeah, about there. So, okay. So that's the receiver basically aligned. So I've got to set the signal generator 0.4 microvolts apparently. So 0.4 microvolt. And I'm supposed to set VR1 to 0.4 to 2 volts on the wattmeter with that turned right up. There. Okay. So, although that's not giving me any signal, we'll see how we go with that. Okay, let's try an actual signal. Let's do minus 67 dBm. It should give me an S9, and it almost is. Look, so just doing that realignment without touching the signal meter setting, it's actually got it really close. So okay, so as you can see, the factory alignment was obviously wrong because all I've done is retune it all, and it's come right. Interesting, eh? So what I'll do now is plug a speaker in and actually have a listen to see what it sounds like, to make sure it sounds right. Yeah, I suppose. Don't know, there might be a bit of noise there. Might be slightly weak still. I might have that last stage not quite set right. Let's just go over again using my ears. It's pretty close. Yeah, that's pretty close, all right. Yeah. Okay. Now let's go back onto the CMU again and let's have another look at that and see what that's doing. Yeah, let's go back to 0.4 microvolt. It's probably boring for you to watch me go back towards, but 0.4 microvolt, same settings as before, and make sure it's doing 2 volts because I've been tweaking that other stuff. Yeah. Okay. Right, so another look at that, -67 again. Yeah, it's about the same, so it's fine. Okay, the next stage is to adjust the noise blanker circuitry, so we'll do that. So noise blanker on. I need to set this up for same as the first step, which it basically is already. I've got to adjust the volume for 2 volts on the output, so I'm doing it now. Yeah, 2 volts, and then I need to adjust L1 for minimum reading, and then turn it 1/4 of a turn counterclockwise. So that's L1 just there. That's the last one I haven't done yet. That's going up. Just want to make sure. It pretty much was at minimum anyway. Pretty much was there. Yeah, it's only going up each way. So minimum is about there, and 1/4 of a turn quarter clockwise. So 1/4 of a turn there. Okay, done. Okay, next thing. It's about setting the sculpture level. So I'll set it up as per instructions here, which is 1500 microvolts. Sculpture fully clockwise in order to fully close it, and you're supposed to set VR3 so the audio just appears on the oscilloscope apparently. So in other words, setting the sculpture, it just opens up. Now VR3 is where? Just there. That's that one there. So we'll give that a tweak, and we'll try and get the sculpture to close. Currently it's open. There we go. It's just closed there. So the factory settings actually bang on right. That's actually just right there. I didn't actually really have to put anything. That's correct. That works. So that's fine. For those interested, that's equals to minus 43.5 dBm. Now, next thing is 100 microvolts setting for S9. Yeah, we'll do that now. Okay, so my after 100 microvolt, and we'll set the S9 reading, which is VR2, which is where are we? Fine, VR2. Pretty sure it's that one. Is it? Trying to get the wires out of the way so I can see. 44, VR5, VR52. It's not that one. That's VR6 at the back. I'm going blind. Why can't I see VR2? Let me know if you see it, will you? Oh, they change the numbering or something. That's the one there. Okay, it's VR5, not VR2. Go figure. Okay, right. So that is now an S9 signal. I didn't have to move much. Just touched it really. Okay, so that's that part done. That's the receive side finished. Okay, next step is start the TX alignment. Now I've already hooked up the oscilloscope to the test point, which is R61. It's a painted resistor wire, well, resistor lead. Well, the other one's got painted leads, this one doesn't. That's usually a good indication of the test point. Apparently I've got to turn L17 and L20 to the bottom of the core, and then adjust L23 and L21 for maximum indication, and then L20 and then L17 for maximum indication on the oscilloscope during TX. So let's wind these right down. Do it gently, you don't want to crack the core, that'd be a bit of a disaster, especially when it right down. Okay, it's right down, and I'll adjust 23 and 21. So 23, this double one here is 21, and 23 is this one here, which I've already dug the wax out of. So let's transmit and have a look. Okay, that's peaked. And L21, this is double one, which is a little bit tricky. Because, like, well, which one do you adjust? Well, yeah. I've actually found in the past these will need tweaking later on anyway. But, that's pretty much peaked anyway, really, actually. Sometimes you adjust these in order to adjust each end of the band. Okay, so that's those. Now adjust L20, which is that on there, for maximum range, maximum signal. Okay, that's now peaked. Then do L17 for maximum RF power. That makes more sense. Okay, so we'll do that. Yep, that's doing 2.5 watts. Woohoo! Massive power. Okay. Then you're supposed to do L14 for the RF power. So let's dig the wax out of here. Now there's a trap over here too, which I'll have to adjust on the spectrum analyzer. Just now the frequencies have changed. It's going to behave a little differently. Wind it in first, dig the wax out, then wind it out. Now usually what I find with these, I have to take the slug ride out in order to get it tuned for these frequencies. So here we go. It's just about there. So it's peaking there, and that's the slug out. So look, that's the slug. That's the way it sits. So what I usually find is I have to take the slug out completely, and that's usually about right. Yeah, okay, looks about right. So that's that part. L24, which is the crystal here. Now you're supposed to trim that for the correct on-channel frequency. Well, that's what the manual says, but really that's a 10.24 megahertz reference. That should really be set to give the correct channel spacings and stuff. You know, so you got 10.24 megahertz going exactly into that. So it should be exactly 10.24 megahertz, not the channel frequency. But because of the way this radio is designed, it should be the same thing. However, because I've got this module in here, it's a little bit different now. So any error in the frequency on this module, you know, because these have a tolerance, they might not be exactly on frequency, might be slightly off either way. So I'll just adjust that, and now I've already actually done that. I've already gone through and done that. So I did that before I did the rest of the alignment. So that's actually on frequency already. So that's fine. That's those. I should check each end of the band. One thing I don't like about this version is that it takes ages to change channels. It's slow compared to a normal channel selector. It's just not very responsive. I don't like that. 1, 2. Nice, got talkback turned on it. Yeah, awesome. Right. Okay, both ends of the band are doing the same power. Quick check. I barely whistle. Yeah, okay. It's tweaked slightly better on channel 1 than it is on channel 40, so I might have to just fine tune that a bit later on. Right, now I need to adjust the AMC circuit, so I need to turn my modulation meter on. That's already hooked up to the circuitry, so I just need to get the thing to transmit, which is, on this case, it's pin 1 and pin 3 of the mic, and I've already got audio injecting in here from my generator. Let's just make sure I've got my settings right actually. Generator level 1. Yeah, I need much lower level than that. It should be 30 millivolts. Yeah, 30 millivolts, 1 kHz sine wave applied to my jack, and adjust the VR4 100% mod. So we shall see what we get. Oh no, now it is. I think I've got a dodgy connection on the front. I think I've got a right angle jack on it, which I think is playing up. One of these. Let's just try and do it without that. Should have to do this on camera, but these sorts of things happen. The reading's not quite making sense, and let's double check it. There we go, now I'm getting modulation reading. Okay, great. That makes more sense. Let's get this set up. So we want 100% mod. And there we go, 100% mod. Done. Right, and then I need to set the TX meter, which is, it says it's VR5, which is the one I did before for the signal meter. I think it's this one instead. Yes, that's the TX meter there, which I've had to turn all the way down. It's giving me an antenna warning, which is interesting. Let's check my SWR. SWR is absolutely fine. So I need to adjust this warning light. There we go. I don't know why it's flicking saying it warning about the swirl. There's nothing wrong with it. Okay, so now I have to adjust this trap to get the least amount of signal out of 53 MHz. So do the same thing there, scrape some of the wax off. I can turn the thing without cracking it. Right. I've got my fish analyzer running already, and we'll just try and turn it. It's coming down. It was about, what was it anyway? Let's put it back up to where it was. That was about there. Let's see what that actually is, shall we? Let's see. Current reading is minus 23 dBm. So let's just turn this up, well, reduce it some more, see what we get down to. Not too far, it's going the other way. Yep, okay, there. That's minus 31 dBm, so I took it down by 10 dBm. So that's the best it's going to get. Okay, so that's the alignment done, and now the only thing to do is to do some on-air tests with it. So let's just do one. I've already got it set up. 1, 2, 3, 4. 1, 2. Yep, that sounds fine. Ignore the hums and stuff like that. It's my various bits of test gear and just induced noise. It's not actually on a signal. If I touch things, it gets quieter. You know, things that need earthing around here. So it's just the way it is. There's actually nothing wrong with that. It's normal. Yeah, that all seems fine. Good positive modulation. That's what it's supposed to be. And check the other one. Check from the radio to the receive side. 1, 2, 3, 4. 1, 2. Yep, so that's all working fine too. So receiver's working alright. It sounds as it should be. Always do a vocal test on it, both transmit and receive, after doing everything else. Because if you've got something weird going on, you may not actually detect it in the alignment. You could have bad caps or something and it will skew something off and you get distortion, or garbled sounds and stuff like that. So I always try and do a verbal check as well as all the other stuff. There's a final confirmation it's all good. So that's that radio done. So thanks for watching. I hope you found it interesting.